This video is about the radical addition of HBr to double bonds. Now recall the addition of HBr to a double bond. You will recall that a double bond acts as a nucleophile, grabbing the proton, forming a secondary carbocation, which then gets attacked by the bromide to form a secondary bromide. We refer to this as Markovnikov addition as it followed the Markovnikov rule, which stated that the nucleophile will add to the more substituted position. Well, turns out that if you do the same reaction in the presence of a radical initiator, implying a radical mechanism, it follows anti-Markovnikov addition, where the bromide adds to the less substituted position. If we delve into the mechanism, it all makes sense. Initially, the initiator decomposes to form two radicals. That radical goes on to abstract the hydrogen from hydrogen bromide, forming a bromide radical. This bromide radical then propagates with the alkene via an addition reaction to form our more stable secondary radical. The secondary radical then abstracts a hydrogen from hydrogen bromide to form our product and a new bromide radical. As we will notice, the initial reaction with the alkene forms the most stable radical, which would be the same as with the carbocations. However, in this case, it is the bromide that is being added to the double bond first, as opposed to the hydrogen. This is why we get the anti-Markovnikov product, even though electronically it still follows a Markovnikov reaction. Here are some practice problems. Pause now, and here are the answers.